Hello everyone, welcome back to the SAS learning sessions. My name is Naga Vimprala. Today we are going to cover hash objects as part of the uh, new session today. So there are what is hash objects? Hash objects are part of SAS. They have been introduced around I think in the 9.2 version. They provide a quick turnaround for memory management. They improve the performance whenever we are doing some lookup or join or joining the two tables. uh, the hash objects they play a crucial role. We can use them in a data step. What we do in data step is we create a hash object, load the large table into that particular hash object, and we can join the other data set against this large table, or we can create two hash objects and we can use them simultaneously also. So overall the memory that hash object can hold depends on the memory allocated for SAS. So there is no limitation. The operation will be really fast because we are going to store this data in the internal cache memory. So obviously IO operations take a lot of time. As we don't have much IO operations here, they are going to give us a better performance. To work on hash objects we have various methods, as you can see here in the slide. Declaring a hash object and defining the key, defining the data, and define done method, and find method, remove output. And there are certain attributes, which is number of items, item size, and deleting the object. And we have some iterator methods, which is to first one is to declare the iterator and then retrieving the first record of the hash object, retrieving the last one, and next one from the current point of pointer, and the previous one from the current pointer. We are going to see these all these objects, methods, iterator, and number of items attribute in today's session. Let's get started. For this particular thing I have a small uh, overview here. What we are going to cover: first thing is we are going to cover a simple lookup of store name using a key. This is one of the data set, variable within the data set, and we are going to have a simple lookup using one single key, and we are going to pull one field through the join. And the second one is more than one key field, that is a composite key we are going to use, and more than one descriptor field, which is nothing but by joining the key fields we are going to retrieve something out of the other table. So we are going to get more columns out of the other table. And then adding entries to the hash object using add method. There are two methods which we are going to discuss today. One I have mentioned, like we will be creating a hash object and then loading the data from another data set. That is one particular way of doing it. Other one is doing a record by record add to the hash object whatever we have created using a add method. And the final one is to remove the record or remove the entry from the hash object. And also we cover how to do iterating the records using next method. And also we are going to create a small data set using output function of hash objects, which what it will do is whatever is the hash object that is we have loaded, the entire hash object we are going to write it out using hash output method. Even we can control what records we are going to write out into the hash object, that also we are going to see. So first one, I have created two data sets. One is a car sales store and the car sales. Let us create these data sets first. Creation is successful. as we don't have any errors, the creation of these two datasets is successful. What we are going to hear in the first simple lookup. In the first simple lookup, we are going to create a dataset name, car sales with store names. So what we are going to do here is there is a dataset car sales underscore stores, which is having car sales with store information. We can see it here. Yeah, we have a store ID, store name, and then the location city. And that particular dataset we are going to load it into hash object using this dataset parameter. So I am declaring a hash object here with the name SC, and I am going to load the data from the dataset work.car sales stores. So this is the way to create a hash object, and I am loading the data from this dataset. And what are the keys that I am declaring is the store ID. This is the first key that I have declared. The store ID is in the numeric format here, 103451, and the one which I am retrieving is store name. So store name I am retrieving from this particular dataset. Okay, here I have just loaded a small dataset here. Instead of loading a small dataset, we can load a bigger one, so that actual memory performance will be really high. But for our demo purpose, I just loaded a smaller table into this hash object, and then once the data portion and descriptor portion is declared, we are going to end the hash object definition using define done function, define done method. So definitely this is going to be there. Without this, we are not going to complete the declaration of hash object. So that ends the portion which we are going to do it in whenever we read the data step with the first record itself. So next one is, once this number 1 is equal to 1 is over, for each and every record, so we have a set function here, a set statement here. So what it is going to do is every record from car sales is going to be retrieved, and but this defining the dataset hash object is done only once, and we are going to do a match. That match is done using find function. So what we are going to do in this find function is, for each and every record in car sales, we are going to find out a match from car sales with store names. So if at all if the match is found, so we are going to retrieve the store name from car sales store dataset, and that is going to be returned to work dot car sales with store names. So let's run this code. So what I got now is work car sales with store names. So for each and every store ID, the corresponding store name is retrieved. If we go to the end, we have a second store ID, shop at true value. That is the second store name that has been sold. So we have done one small lookup here. So moving on, we have the second requirement, which is to use a composite key. For that, I have taken different data sets overall. The car sales, again, I have not used. I have just small data sets this time. So overall, we have covered that hash object, how we are declaring, and how we are doing a simple join, which is using object name dot find function. With that, we are doing a lookup. The second one is, we are not going to cover the memory management or anything here. Simple join, but here we are using the key as composite key. That means multiple key columns we are using, and we are retrieving multiple attributes also. So let us take dance class, where we are having the student ID and when the student has been registered for this dance class. In the second data set, all the extracurricular activities, whatever the students have been registered, we have with their ID, name, and when they have registered and what is the activity that they have registered for. So let us run this code so that the two data sets are available. So I have both the data sets available. Now what I am going to do is look up using composite key. Here the composite key is ID and registered date. So the same way again we are declaring the hash object. So first of all, whenever we are doing working with hash objects, we are going to remember two key things here. Hash object is available only for data step. It is not available for any of the SAS procedures. Only advantage that we will get out of hash object is better performance whenever we are doing a match merge, lookup, or these kind of joins. So based on the requirement, if we are going to handle that requirement out of data step, we can go with the hash object. And only thing that we need to keep in mind is the limitation on the memory. If we have ample of memory allocated for SAS and even the millions of records it can handle, the limitation is the SAS memory. How much is the memory allocated? So at a time we are going to load the complete dataset into the hash object. So that is the maximum memory it can occupy. Apart from that, if we have everything proper, it works perfectly fine. So whenever we are declaring a hash object, first thing is declare the hash object. Either we can create it using a dataset, or we can create an empty hash object and then load it using add function. That we are going to see later, but this is the first one. Dataset, using the dataset we are loading the hash object and then defining the key and defining the data. Definitely key should be at least one key field should be there. Here in our case we have two, but bare minimum at least one key field should be there. And for defining the data, either we can use the data or we need not have any key fields. If we don't have anything, just it is going to use for whether the record has been found or not. If the match is successful, hash object dot find function, it is going to retrieve 0. So whenever we get whenever we get 0 written code out of this particular function, that is the key field is matching from whatever the data step record that we have for this particular data set, and uh, the data set we have loaded into the hash object. Here in our case we have loaded dance class, we have loaded all the classes we have loaded, and we are going to verify that particular record one by one into from dance class against the hash object records. So here I have set dance class, which is these three records I am checking. So this data step is going to run for 3 times each for each record from dance class. Now I have loaded 5 records into hash object. So the first one 1054 and 5th February 2016, it is going to be the composite key verified against the hash object records. So we have a match here, and then 2031 and 1st February 2016, even it is having a match here. So these two records are matched here, and then the third record is verified, which is 3055 and 30th January 2016, but we don't have a corresponding match here. So the h.find method returns 0 for these first two records. So whenever it is equal to 0, then only I am writing it to the output. So I have to get 2 records after running this particular piece of code. Exactly, I got 2 records after running the code. So this is the way to use multiple keys, composite key, and retrieving more than 1 or more than 0, to be exact, more than 0 records from the data records. So here we have used 2 keys and 2 data fields we are retrieving out of this hash object join. The third requirement what we have here is we are loading the data into hash object using using add function. So only difference here is I wanted to explain a way to add records to hash object using add function. I have created a hash object with the name just h, and I am not loading the data immediately during the declaration time itself. So what I am doing is, instead I just declared a key field id and registered date the same way. Here I am not going to do anything new. The same requirement, instead of loading the dataset prior, I am loading the dataset later using add function. And in the first record, whenever n is equal to 1, that means bare minimum, the first time whenever we are executing the data step, I am declaring the hash object and declaring its key and data fields, and then completing the define portion. Later I am setting the records one by one from all classes, and a new column, a new flag I have added, end is equal to all classes end of file flag. So I am going to retrieve each and every record from all classes one at a time, and that each record I am adding. So before doing this add, we can do some checks whether we need to really load the table into hash object or not. So this is one feature. Just with the add, we can build the hash object dynamically. Here we don't have that capability. If we want to load the entire data set, this is the best way. If we want to do mm, some kind of record drops, or if we want to do some manipulations before going ahead with the add function, we can do that and issue record by record load using this kind of this kind of approach. So here I have loaded all the records till end of the file using this add method, and just a small display statement I have used, which is of no use here. And then what I am doing is, for each and every record from dance class, I am checking if there is a corresponding match, the same way what we have done in the previous example. Then if the join is successful, I am writing out the output. So even this approach should result me the same output. So exactly we got the two records whatever we have received in the previous example. So this is one way of adding the records to hash object and doing a lookup. And now finally the last example we are going to see here for today, the remove function. We are going to see how to remove a record from the hash object, and then how to iterate through the records using um, hash iterate steps, iterator. Okay, basically hash object and there are hash iterator object, two things provided by SAS. What I am going to do here is, we have the records like this: Tom, Vicky and Lisa. Lisa has 3 entries. She has registered for art class on Jan 29th, and she has registered for music class on 31st January, and again there is second registration on 10th February. So whenever there is a latest entry, I have to discard the previous entry for the same type of extracurricular activity, and I have to consider only this 10th February. For that reason, so before loading the what I have done here is, I'm loading the data into hash object, and the same all classes method I am going to verify and check wherever the match is there. I am going to write it out into the output dataset. So for this particular reason, uh, okay, one more thing we are doing out of it. Here we are creating a test dataset out of this particular data step, where we are writing it out. H dot output, as I have mentioned previously, it will print out all the records from hash object. So if we have 5 records will be sent out into the test dataset. If we have just 4 records, those 4 records will be sent out into this test dataset when we issue that particular output method of that particular hash object. The hash object name I have given here is H. So first thing, I am just declaring a hash object using declare function. I mean declare statement. Declare hash and the hash object name H, and without any dataset or any parameters. So we are not loading the data here. And in the next line, I am defining the key. Key here is ID, registered date, and the class name, because we have to check for the registration date, the latest one we have to see, and then the class name. So if the same class name is there, then only we have to consider the latest record. And then I'm ending the definition. Now I am going to load all classes. So let us see what we have in all classes. Yeah, the same data we have. 29th January, 31st January, and 10th Feb records we have. But we, for music class, we have two records: 31st January records and 10th February records. So now I am reading record by record. Again, this is a simple display statement which we don't need. I'm removing that. So I'm loading record by record, and I just issued a retain function. We have seen this retain statement, what it is going to what it is doing. So if we pass the next data record, whatever is stored in retain ID, usually if we don't give this retain ID in the retain statement, that is going to be wiped out and clean slate. The vector data vector will be clean slate, and we are going to have a new value for retain ID in the next pass. But when we issue this retain statement, the previous retain ID will be retained until and unless we are going to touch it and change the value. So here I am setting this retain ID as ID. So in the next iteration also it holds the previous ID. So whenever there is a change in ID, then only, where is it? Yeah, if the ID is equal to the retain ID, that means the values are same. Here we are going to have the same retain ID, and class name is equal to class name, but here the class name is not equal to class name. So here when we encounter this particular record, this condition is going to be satisfied here. When the class name is equal to class name, then what we are doing is issuing a remove statement. So we are issuing the remove statement using the retain ID, which is nothing but 3055, and registration date as it is a retain registration date, so it is going to hold 31st January 2015, and then the class name as music class. So this particular record is going to be in this key field. So whenever we are removing a record from hash object, I have mentioned that particular note here. When we issue remove statement, cursor should not point to the record which we are trying to remove. That means we are on the same branch of a tree and we are trying to cut down that branch. So which is not really a logical way to do the thing. So we should be, if our cursor is here, if I don't issue this key command, I am going to stay with just ID, registration date, and class, which is the last record, and I am trying to remove this particular record itself. So system doesn't allow it, and we get some error which is not allowed. But here when I am trying to remove this record by staying here in the cursor, I can remove the record. Okay, then I am issuing a statement h dot remove that particular with the key values, and then if I get the return code 0, the record deletion is successful. If I don't get the return code 0, then the deletion is not unsuccessful, and I should get this message in the log. And for other keys apart from this particular remove key, all other cases, the record should be added, the current record should be added, only the old record will be deleted. So once we are done here adding the records, this is the end portion of just loading the hash dataset, hash object. And once we are done with loading the hash object, we have another function, another property or attribute of hash object, which is number of items. So what we are going to have here is uh, how many records are present in this particular hash object. In our case, we are going to have four hash objects after removing this particular record. So four entries we should have, and this hash object I am saving in number of items. So I am declaring a iterator, declaring iterator whenever we have number of items greater than 0. So we have some hash objects in the data, in the hash object internal memory, and I am declaring a new iterator with the name hi. So the iterator, we are what we are going to do is we just display whatever we have in the hash object to see that to make sure that whatever the operation which we have discussed here, the same way that whether the logic worked or not. So with the few display statements, do until the return code is not equal to 0. So whenever we are able to read through completely this hash object, we are going to have return code 0. Even this next operation, it results proper 0. Once we move the cursor beyond 4 records in this particular h hash object, the return code will not be 0, and we will be terminating this do loop inside, and we will come out. And finally what we are doing here is we are creating a test data set with the hash object whatever we just created, the hash object h. So all the four records will be written out to test data set. So overall this data step is going to be executed only once, because we don't have any set statement here for this data step. So everything is going to happen from first line to the last line till run statement only once. So let's run this code with the 5 records whatever we have in all classes. As expected, I got this test dataset created with whatever the records I have in hash object, and also the all extracurriculars. In the all extracurricular, as expected, it ran only once, and the return code I am saving just 0. And number of items, this is the one which we are really concerned. The number of items, it displayed properly as 4. So in the log, let us see whatever is displayed. Yeah, we got the message. First of all, record removal is successful. And so where else we have the put statement? After record deleted, we have a put statement here. Yes, the first put statement is whenever we for the first record. Okay, that is for wiki. And the second put statement is for music. We have latest entry 2/10/2016, and yeah, the art class, it has been displayed twice, because once it is for within the loop and the other one is outside the loop. So we got two times the put statement, but overall the 4 records are displayed. And finally the h dataset is written out. We have h data, the hash object created out into the test dataset with 4 observations and 4 variables. And even we have a note saying that 5 observations are read from work.all classes, but only 4 are loaded into hash object, because we have used a remove function. So this is all about hash objects. So just I have added one small exercises kind of thing for this session. Let's try it out on your own. Those exercises are: try some dataset options. While we are loading the dataset, while loading the dataset into the hash object, we have mentioned dataset, or we just declared and loaded it using add function. But in the dataset also, we can give something like where, and we can mention whether class name in dance or whatever it is. We can control the records by giving some where condition. So such kind of parameters we can pass, and we can issue that we can control the records how many we are loading into the hash objects. That is the first exercise. Try dataset options as mentioned in the above syntax to select only few observations. And second exercise is try dataset options while loading the data into hash object itself. Here the syntax whatever I have given is for writing out the output. Even in writing the output outside, we can give the where condition, and we can control the number of observation which we wanted to write. The same way we can load the hash object with the number of records whatever we are trying. And finally we have another method, a sum method, which we have not discussed here. That is to perform some summary operations on the keys whatever we have. Just go through this sum function and try to implement it in the data step. Okay, and we can save the values into the data step variable that can be loaded, and we will be able to see it. So that's all for now. We have discussed ample of things, very crucial and important discussion, which improves the performance of joins, match merges, and lookup in SAS whenever we have a data step involved, where we can handle creating the hash objects using the data sets. So that's all we have. Thank you.